Excellent. Yes, so we'll be doing this live. Just put any questions that you might have in the chat. And if I'm going just way too fast for everyone or too slow or something's not clear, then Nico or someone else will interrupt me and we'll get things clarified. Otherwise, just feel free to put all questions in the chat. Others, are familiar with the frameworks that we're going to be working through today and can hopefully help you get unstuck. And you don't need to be you don't need to be an AI expert here. In fact, if you're feeling kind of confused by AI or don't know exactly how it fits into your workflow, then this actually may be the tutorial for you. You don't need to be a Python wizard either, but you should hopefully have some knowledge of how to install things on the command line and how to open things in an IDE. So this is what I put as the prerequisites, just a bit of basic knowledge of Python, getting UV installed locally. There are some instructions here if you want to get started with that as we go through. Some kind of IDE or text editor. And then to make this easiest, it really helps if you have an OpenAI API key. It is possible to do this using Claude instead. It is possible to do this using the Google API, or even if you're from a Berkeley lab and you want to use the Seaborg proxy, you can do that too. But we'll be just assuming that you're doing this the most straightforward way, which is via OpenAI. We'll use GPT-4o as the default today. But if you really want to try something else, then maybe someone in the chat will be able to help you. Okay, and also just some basic knowledge of the ontologies that we use in Monarch, including the Uberon multi-species anatomy ontology, and the ontology access kit might help as well. So, okay, hopefully you've all got UV installed so far. Here's some instructions here. This may be surprising if you're from the Monarch project, because as you know, we tend to use Poetry a lot in Monarch and Obo, but some of us are starting to explore UV as an alternative to Poetry as a package manager. One thing that's nice about UV is it's actually rather fast. So let's go ahead and get started. We're going to copy this first command, create the repo. I'm going to navigate over here just to a temp folder. I'm going to run this UV init, and then we're going to give it a name, which is agent tutorial. What I suggest is you don't have the repo for this tutorial checked out. It's got the same name. We're essentially going to be recreating it, but you have that there in the background in case you need to refer to it. And of course, after me saying UV is super fast, it appears to be stuck here. How are you all getting along with this command?
That was instantaneous for me.
All right, off to a great start. Oh no.
You can maybe do a git clone instead, Chris.
Oh, you can hear me? You're all frozen. Oh dear. Okay. I don't know what happened there. My entire machine froze. Great start. All right, can you even hear me? It's telling me that Zoom needs to restart my audio. My apology, I've never seen this before.
There was a major Zoom update before, so probably that made it happen.
Okay. Can you still hear me?
Yes, we can hear you.
Okay. I'm really sorry, everyone. Okay. I don't know what was up there. So let's carry on, and hopefully there's no more glitches. So it did actually work, but let me just demonstrate that it does. All right, that time it was very fast. Now, hopefully you're all ahead of me here. We're going to navigate into this directory, and then we're going to add a dependency to a package called Pydantic AI. So here we go. And again, yes, very fast. Okay, it's installed all of the dependencies. So Pydantic AI, you're probably familiar with Pydantic, but Pydantic AI doesn't actually have that much to do with Pydantic itself. It is one of the many, many agent frameworks out there. And if you've ever looked into agents, you've probably been quite bewildered by the sheer variety of different options out there. There's LangGraph, and which is somewhat different from LangChain, confusingly. There's also Crew AI, there's small agents, and seems there's a new agent framework every week. We're going to be using Pydantic AI. We've been using it in a project in Monarch called Aurelian. It's there's many good things about all of these frameworks, but we selected Pydantic AI just because it seems to have nice documentation. It's simple, it's straightforward, it kind of follows a lot of the kind of principles that we like in a lot of Monarch projects. It's designed to make to use type checking and so on, and it is able to use Pydantic objects. So what we're going to do is we're going to open the project in our ID of choice. I'm going to do this in Cursor. So we're going to go over here and open our fresh new project, which is mostly empty other than things that UV has set up there for us. So it's made a little git ignore and so on. So we're going to do open a new file, and it's going to be called hello world.py. And then we're just going to copy this from here, which is also the exact same, not particularly interesting example that is in the Pydantic AI tutorial. Just going to remove this here, and then we'll just walk through this. So basically this creates an agent. It's not a very interesting agent. The fun thing about agents is that they typically have something called tools, but this agent has no tools. So it's just basically a bridge into a normal kind of LLM type API. So this is hardwired to use the OpenAI GPT-4o. So hopefully you've got your API key set. There's a system prompt, and then we use this run sync command and just pass in our query here. So we're going to run this like this using the UV run command. This time I'm going to do some of this from directly from the terminal here. And yeah, this will send our query to the LLM and we get back the answer to our query. And you probably won't get the exact same answer here, but you'll probably get something along the same lines. So how are we all doing so far? Thumbs up if we're getting this this working. Great. Mm-hmm.
Chris, can you say, is there any fast answer for what to do if we did check out the repo and we got you've got two workspaces when we did UV add?
If you've checked it out, then don't do UV add, I guess, because it's all been done for you already. So I would say your best bet is to just kind of like, you can either just use UV run to follow along if you've got things checked out already, but then that's, you don't get the experience of doing each individual part by itself. So hopefully that helps, and hopefully someone in the chat can help there.
Thank you.
All right. And just, the other thing to be troubleshooting is if you might not have the OpenAI API key set on the command line for that to work. By default, Pydantic AI will make use of your environment variables. If you are, feel like you want to try doing this with a different model, you can you can kind of like, change this here. If you do want to use a proxy, such as a Seaborg proxy, there's some instructions here at the bottom of this tutorial for being able to do that. But if we're all okay, and just slow me down, if not, we're going to go ahead and start making our first agent next. So we're going to, in the same folder in our agent tutorial, we're going to use uv-add to add a new dependency. Now, this may not actually work, but don't worry if it doesn't. This is partly, we're still kind of exploring UV and looking at some of its quirks. What you may see the same thing that I'm seeing right here is it actually slows on building, it's trying to build one of the packages that it finds within the set of dependencies. So this is not ideal, but it so happens we've got kind of like a fix for this. And this is just something that kind of happens in the Python universe occasionally, that you have a dependency and someone forgot to build a wheel for a certain platform along the way. So what we're going to do is we're just going to kind of like pin that dependency to an earlier version here. And hopefully there will be a wheel built for this for version 0.13 later that we will depend on. So did anyone else see the same phenotype that I did there, or did Oaklib install for you on the first go? All right. Okay. If we've all got that working, then we're going to create a new file within agent tutorial, and this one is going to be called Oak Agent. So new file.
For some people, it worked on the first go, Chris, just so that you know, three people.
Mm-hmm. Yeah, I think it's platform dependent. I think there's a wheel missing from, some Mac platform, or it might be something odd with my setup with Rosetta. But anyway, very good. Just let me know if people need more time. Otherwise, we'll move on to Oak Agent here. So we're going to copy this code here, but the same code is also in this repo here. So I'm just going to get the whole thing, which has the all of the imports as well. And then we'll copy that over, and I'll walk through what each of the parts of this do. So just as before, we're going to set up an agent. This one is called Oak Agent. One thing that's maybe a little bit unintuitive about Pydantic AI at first is you always use the same general agent class, and then you essentially set up a global variable that is used everywhere that can be used to interact with that agent. So our Oak Agent looks like this. It's got it's hardwired to talk to GPT-4o, and the system prompt is, you're an expert ontology curator. Use the ontologies at your disposal to answer the user's question. AIs don't care about punctuation, but we'll fix that anyway. Now, what is different here is that we're going to define a tool that can be used with the agent. And so Pydantic AI makes use of a Python feature called decorators. And the basic idea is you can define just an ordinary Python function, and you decorate this function in a way that advertises it to the tool. So this is a function called search Uberon. Well, let's look at the arguments. The arguments is a term, the term that we want to search for in the ontology, and then it results a list of tuples, each containing an Uberon ID and a label. And then, just as if you were writing a function for a human being, when you write a function for an AI, you want to document it and clearly explain what it does and what you might expect and not expect. So here we're saying the search should take into account synonyms, but sometimes synonyms in the source ontology may be incomplete. So if you can't find a concept of interest, try searching using related or synonymous terms. If you're searching for a composite term, try searching on the subterms just to get a sense of the terminology used in the ontology. So these are kind of exactly the instructions I would give, a human who is just using something like the OLS API, for example, to search for a term. So, if we were searching for kind of like something like, the fingernail of digit 1 or something like that, I might, you might first just do a search for fingernail and see, oh, okay, yes, it's got this strange name like nail of manual digit, and then maybe we say kind of like finger 1, and then it will say, okay, manual digit 1. I'm getting a sense of the terminology now, so maybe I can say, do a search for kind of like fingernail of, or just nail of manual digit 1. So I'm basically kind of like, as a human being, I'm kind of just exploring the search interface here to be able to say, oh, okay, yeah, this is the concept that I'm interested in. I might not have found that on the first attempt, but as I kind of like explore the ontology, I get more of a sense of it. So anyway, let's move on to the actual implementation of the function. So I think many of you are familiar with oak. With oak, the basic idea is it provides a uniform layer, access layer onto multiple different ontologies and ways of accessing these ontologies. We're going to use a method called OLS, which is basically a shim layer on top of the OLS API, and we're going to hardwire it to be to create Uberon within the OLS. And then we're going to call the oak basic search function using the search term. We're not doing anything fancy here. We're not doing any kind of like regular expression search or semantic similarity search, or it's just a plain old search using the OLS's quite nice search functionalities. You can change this if you like. You can use BioPortal. You can use the semantic SQL version. The OLS one is just kind of quick and straightforward to set up. It doesn't require downloading anything. It doesn't require any API key, so we're using it here today. But you can experiment with different ways and different ontologies. Then basically we're using this oak labels function that will take the iterator over all the identifiers that come back in basic search and return a list of ID labeled tuples. And then we're going to use a very advanced debugging technique here using a print statement just to because this is kind of quite a nice way of seeing what is going on with everything, and then we return those labels. Then finally, we decorate the function using this tool plane. And if we have time later, we can talk about other kinds of non-plane tools and what that means. But most of the time, this is all you need to do is just write a basic Python function and then register it with the agent using this decorator. And then this time we're going to use a rather than just kind of hardwiring the query itself, we're going to make a little click command line interface onto this. So it's going to be a very simple command. It's going to take one argument, and we're going to even have a default here for that, which is what is the Uberon ID for the CNS. And then all this command does is use the oak agent, and it calls runsync just as we did before. So if we're all comfortable with that, we can try running this next.
Chris, just a quick question. Does the doc string of the function that you've defined, is it read by the agent at all, or is it just for yourself?
It is, yes, very good. Sorry, good point. Yeah, the doc string is read by the agent, and the args are also read by the agent. So just a general good principle is, the kind of things that a human being might read are the things that the agent will read as well. All right, so next we are going to run this. I'm just going to run it with the help option, except I didn't add a help option, so it's not actually doing anything there. Sorry, just to minimize confusion, let's run it without the help option. Now this may be a little bit slower than before, because it's not just doing a straightforward single query onto the LLM. In general, we never want to query an LLM with something like, what is the ID for term X in my ontology? Because there's a high chance it will hallucinate it. So instead, what is happening here is that the AI, the AI framework, Pydantic AI, will basically query the LLM and say, here's the user's query. What of the tools available to you, and in this case, there's only one tool, which tool would you like to use to answer the user's question? And then the LLM will say, it looks like this search Uberon term is highly relevant to the query of what is the Uberon ID for the CNS. And so it will say, I want to use that tool and I want to use this argument. And it passes that argument. And we can see that because of our very advanced debugging here. It said, okay, we got a query, we passed that query to Oak, we got back all of these terms here. And just because of the way the ontology search works, it's not necessarily the case that the most relevant one will come back first. We don't care about that because the AI will just look at all of these search results and say, yeah, I don't care about that one. I don't care about tectobulbular tract, but in amongst all of these is the term for CNS, and then it will actually return that term here with the correct ID. All right. Did we all manage to run that, and did we all get the same answer? Anyone get a different answer or? All right. Just assume that I'm not looking at the chat itself, but waiting for Nico or someone to interrupt. Okay, if that all seems
Tim
to
just
work.
made an observation that that his agent returned only a query, whether that's expected, and we had one person that tried to run it with 3.13, which didn't work. The install didn't work.
Okay, sorry about that. I should have tested with
The install actually worked. It failed in like a deep part of LinkML runtime, which is not, I mean, it's not a big deal.
Yes, okay, yes, we're working on that.
Oh, good.
Yeah. All right. No, but very good point about the query, because we left this kind of query quite open here. We didn't say what format we wanted the ID in. And when I ran it, it just so happens that it's probably familiar with some of our own documentation where we often write things, with Markdown and, and link like this. We can give it a more precise query like this, and we can say, what is the and I can say return only the ID, no other text. Later on, we'll get to a more kind of sophisticated way to do the same thing, but it's not unexpected that you may get slightly different answers, when you give it an open-ended query like this. In this case, this is all, just to be clear, this is all the debugging that we added here. This is the actual output of the command. Yes, Mark? Mm-hmm.
Can you say anything brief about your choice to use Cursor as opposed to the Claude Code plugin or some LLM features that are built into other IDEs?
Yeah, I love Claude Code, but I don't think it would be a good thing to use for this tutorial here because it's the whole point. Yeah. I don't think vibe coding this, would be super informative for things. But really, honestly, you can use whatever IDE you like. You could use Vim, to follow this tutorial. And I think, like many of us, I'm just, kind of exploring some of the different IDEs. I personally found Cursor to be quite powerful for its AI autocomplete features, which we're not using here because I'm mostly copying and pasting code in. Personally, my brain is a bit more hardwired towards PyCharm and some of the key bindings that you get there, and I find some of the kind of Cursor is essentially a fork of VS Code, and I find it a little bit less fully featured, but it really doesn't matter. Just use whichever IDE you like here.
Chris, is there a way to use a local model for this tutorial instead of OpenAI's? It's how are the local LLMs being talked to exactly?
So that is usually that depends exactly. I think the way many people might run a local LLM is they may use something like Olama or here we go. So you just look at the model section of the Pedantic AI docs here. If you're running Olama, basically wherever you, in place of where we hardwired GPT-4, you could just do this. Great, say Olama model name, and then provider. And then really you can use, you can also use really any, what's surprising is they don't actually have explicit documentation on Light LLM, but for those of us at Berkeley Lab, we have access to multiple different models via a proxy. There's essentially a Light LLM proxy called Seaborg, and the way you would do that is using, by setting things up like this. So in theory, it should be pretty easy, and the Pedantic AI docs are pretty good, and there's good kind of like support on the issue tracker if you're having any issues there. All right, so if we're okay to move on, next up, we're going to create an annotator agent. So this is going to follow on from the agent. It's going to make use of the tool that we defined before. So what we're going to do is we're going to create a file called annotator agent in the same folder, new file. All right, so I'll kind of try copying these, piece by piece as before. I'm going to walk through each piece as I copy them in, but you can just kind of copy them all in en masse if you want from either the tutorial or from the existing repo. So so in this case, we're going to make use of more structured responses. And so, as we might expect, we're going to make a little data model for our structured responses. We're going to build essentially an annotator here. It's going to be a general purpose annotator, and the data model is going to be simple, essentially tuples, where we feed in the text. We get back a bunch of text annotations. This is not too dissimilar from the Oak text annotator data model if people have used that. We could have even reused the data model for that if we wanted to, but we're just kind of keeping things simple for this tutorial. And so a text annotation is basically just the chunk, the span within the source text, the ID of the concept, and then the label of the concept. And we're being very hardwired here and saying this is a text annotation for Uberon. Obviously, you can make this more general purpose if you want. And then we've got some documentation for the model here as well. And then just to maybe over model it somewhat, we're creating an object that holds a list of these text annotations. So with that, we'll go on. We'll create the actual agent itself. Now, okay, so sorry, I put Claude there. Let's just stick with OpenAI GPT-4o for now. I have tended to find that Claude just seems to be better set up for agents. A lot of these different LLMs, they've through their kind of like the reinforcement learning, they're often kind of given kind of like tool forming type examples that help make them more well suited towards being an agent. And you may find this with some of the local models as well. It just may not work quite as well as some of the other models out there. Okay, but this agent has instructions to extract all Uberon terms from the text. So the idea here is we could give like an entire paragraph and have it return basically every single case of the mention of an anatomical term within it. So, and we're also kind of instructing it to maybe help find gaps within the ontology as well. So if you can't find the Oberon ID, but you think it's an anatomical entity, still return a text annotation, just leave the ID field empty. And then this is maybe seems a little bit redundant, but we've found it can help to just really reinforce certain kind of pieces of instruction that you might give it. Now, what we're also doing here is we're going to reuse the tool that we defined previously, the search Oberon tool. So we're going to need an import for that. I don't think we need all that. Sorry. Let's go back to, I'm just going to copy the imports from over here. This is the kind of crucial one here, this last one. So this is the same tool that we defined earlier in our Oak agent. We're just importing it here so we can reuse it. Now we're going to essentially copy the rest of this here, and the rest of this is really just kind of boilerplate click command line stuff. So we're even going to give it some default text here. The default text is designed to be the kind of thing that might confound a very kind of like simplistic lexical annotator, because we're putting kind of like things in parentheses. Hippocampal CA1 is located in the forebrain. It projects to the amygdala, subiculum, and the entorhinal cortex. So, there's about 4 or 5 different kind of like ontology terms within here, depending on how you do it. And then we just have pretty much the same kind of agent as before. Oh, I'm sorry. One crucial difference with this agent, though, that I forgot to mention. This time we are passing in a result type. And that result type is this text annotation result that we defined earlier. So before, we were just getting back text as results. This time, it returns an instance of this Pydantic class. And due to the magic of Pydantic and Python type annotations, if you are using an IDE that is type aware, it will like not complain that you are this result object has this annotations field within it, because it knows that this is an instance of text annotation, which has all of these fields within it. So we're just going to cycle through all of these results and print them. And let's go back and find our command. And again, this may take even longer than before, because the AI has to run multiple different subcommands along the way. So let's go over here. Let's clear this, and then did I hit save? It's another difference with PyCharm. PyCharm auto saves, I think. All right, so this is the debugging information. It actually wasn't too slow there for me. So again, this is all debugging. You can see this time it's actually done multiple different queries. And then this is our print statement here, print result, and it's found essentially 5 terms here. CA1 field of the hippocampus, and again, this is the text that it thinks it matched. This is the actual label in the ontology. So even though these ones are kind of like trivial, this one was a little bit harder for it because I didn't specify the exact term or an exact synonym within the ontology. Now, did that all work for everyone? Did you get massively different answers? Did you, Mark? Mm-hmm.
Oh, I can ask my question after people say whether it worked or not.
Mm-hmm. Give a thumbs up on your Zoom if that worked for you. Mm-hmm. Excellent. Mm-hmm.
Some people shared their results so that you, if you want to look at them real quick.
Okay, yes,
Chris.
I will take a look at the chat. So,
Chris, can I ask a question?
wow, that seemed to work for a few people. I'm kind of amazed. It's Justin. Mm-hmm.
was going to ask if this would deal with misspellings, or how would you suggest sort of insinuating that in here to deal with?
Yeah, let's give that a go. Let's make up some text that says the forebrain is part of the Brian in humans. I have no idea if this is going to work or not, but and it did indeed.
It's pretty good.
And why did that work? Well, the reason is because we're not just kind of blindly pasting these strings into an ontology search. Again, the Pydantic AI framework will present the user's query to the AI and say, these are the tools available. How do you want to use them? And the AI is, I'm sorry to use anthropomorphic terms here, but it looks at the query and goes, I think the user actually meant to say forebrain and brain here, so that's the actual query I'm going to use in my search. Makes sense. Go for it, Mark.
Yeah, I'll ask my question now because I want to think about how early in the process to do spot checking. Like I don't know. You asked everyone how do your results look? Is that the debugging that you would do? That you would look at your results or you'd compare results with a colleague? Should I sample some fraction of these and just run them against the Oaklib annotator the way that I know? Like, how can I take some of that black magic experience out of it?
You have hit on like the fundamental kind of question of the last 2 years of how we use all of these. And basically there's two answers. You either kind of like vibe it or you do kind of like formal evals. And I really think it's really useful to kind of like vibe it at the beginning. You just try some examples and get a sense of how well these things work. But I really think when all of us use these, we should be getting into more of a kind of an evaluation mindset. And this really applies to kind of like all of us in all of our projects, not just us as developers. We should be working with curators and ontology editors and kind of thinking, what are a good set of test cases to know if this is really working? And no one quite knows exactly what the best overall approach is here. We can look at the Pydantic AI documentation. It's got a really nice section on evals here, and they used to have a very witty, funny comment up at the top here, but here we go. Unlike unit tests, evals are emerging art science. Anyone who claims to know for sure exactly how your eval should be defined can safely be ignored. So good, I'm glad I didn't start the answer to this by saying that I knew all the answers. But yeah, with that qualifier, there's some very nice documentation on how you might do evals, and they've recently added something called Pydantic evals. And the basic idea is you define a set of test cases, and there's different ways to evaluate it because there's not always a kind of crisp right or wrong answer. There's patterns like using an LLM as judge and so on. So I think that's a really nice step for people who want to kind of take this further, is to take a look at the Pydantic evals package.
Thanks.
Nika? Mm-hmm.
So just a quick question about the redundancy with between, for example, the annotation model and the instructions you're encoding in the prompt. So one thing is do you have any intuition where you would put most of the kind of understanding of the information that you seek to extract? Is this something that you would rather stick in the prompt and tell it, okay, you have this field and that field in the annotation model, you put this there and that there? Or is this something that you would put in the description of the data model? And related to that, if let's say the answer would be put it in the data model, what's your feeling about generalizable data models for knowledge extraction, wouldn't it then be most likely to be better to always have a very specific model defined for each and every agent that is like exactly the fields for each that have to be extracted, even if you were hinting at it before, could theoretically have defined this now as like ID and label and just say, this is the ontology ID, this is the label of the ontology term, while right now you're saying, this is the anatomical entity in Uberon, something like that. Do you see?
Yeah, no, I definitely, I don't have all the answers here. Some of us are really just embarking on this kind of like exploration of these kind of agent frameworks. I'm hoping quite soon some of you will kind of pick all this up and we'll have some of the answers. I want to say that we should define our functions and our data models the same way we would for taking into account modularity and good engineering practice and following good software engineering principles like dry, don't repeat yourself. And I think that does tend to work to some extent, but there are cases where it does help to be maybe just tune the data model a little bit more towards the use case, or to err on the side of a little bit of redundancy. But to be honest, I've not done the actual evals to say that is necessarily the case. That's just based on some ad hoc kind of experimentation with these things. In this particular case, it doesn't need to be as hardwired as this. You don't need to make an Uberon text annotation and a Go text annotation and a Mondo text annotation object. I just made it this specific just because this is, just to kind of keep it simple for this tutorial. Tim. Mm-hmm.
Yeah, thanks, Chris. This is a great tutorial. Something that I've been wondering about a lot, especially playing with like OntoGPT and looking through other packages, is has there been any thought to comparing this approach, which is kind of a zero-shot approach or what have you, with a fine-tuned model? And could something like this be used to like annotate, let's say you annotate 1,000 papers with Uberon terms and some human editor verifies the annotations, and then that gets used to fine tune a model to potentially make a really efficient targeted model?
Yeah, I mean, others here who may have kind of experimented with fine tuning may want to kind of like pipe in. I think within Monarch, we've not really explored it that much, and what I have, tend to see, is that in theory, the fine tuning can, really help you with a kind of specific kind of problem. And people were doing this kind of quite a lot with the early days of LLMs when they weren't quite as good at following your instructions. But what a lot of people tended to find was that fine tuning would give you some boost at very specific tasks, but the model would tend to lose some of its generality that is actually what you want. And especially for these kind of like agent type tasks where it's much less, here is your specific hardware task. It's much more open-ended, where you kind of like give it something kind of quite general and let it figure out how to do it for itself. So basically, yeah, others may vary, but I'm not so super enthusiastic about fine tuning for this kind of task.
Thanks.
Hussein? Mm-hmm.
Is there an easy way to deploy these agents and make them work behind the chat UI?
I'm glad you asked that. Yes, there is. You can, of course, this is just normal Python code. You could write a fast API, layer on top of this, and you could, build a React, UI on top of that, just as you would for any other Python. But just as with a lot of these kind of like AI frameworks right now, there's people are using kind of like Streamlit and Gradio and things like that just to make kind of like quick and simple type UIs. So that kind of brings me on to what you might want to try as your next step. But before we do that though, I just want to sort of tell you all, what you just did there with this kind of simple agent, is the kind of thing people would have spent months kind of like weaving a very kind of like particular kind of like text mining platform and chaining together grounders and named entity recognition and lexical matching, and it's the kind of thing people would have spent months on and then written a paper about it. You've all just written an annotator, with a couple of lines of Python code. So you should all like pat yourselves on the back and feel quite empowered to do some really kind of quite powerful things with agents now. And hopefully that has given you a sense of what is possible here. But just to kind of like segue into what you might want to try next, we've been building this I was going to say framework. It's not. It's definitely not a framework. It's a kitchen sink of different agents that are useful for a bunch of our different projects in in Mark and LBL and Go. It's called Aurelian. Maybe that name will stick. Maybe not. I'm terrible with names, sorry, but agentic universal research engine for literature integration, annotation, and navigation. It also happens to be an old name for a Lepidopterist, so it's quite appropriate for the Monarch initiative. But you can kind of like check out this this repo here. You're all welcome to make contributions to it. Warning: it's not necessarily the most super polished code. The idea is not to have something that is 100% stable. It's more just as I say, a kitchen sink of different agents, and the way we've kind of organized it is to try and make things as kind of insulated from each other as possible. So maybe some of the bridge for AI people are contributing to the D4D agent, some other people are making the chemistry agent, some of the Monarch people are making the diagnosis agent, and you can reuse tools from within each of these, but we're often kind of like just working on these things independently. So this could even be split into multiple different repos, but it's kind of handy for various reasons to keep it in one repo at the moment. So so there's a lot of different agents here, and just to go back to your question, Hussein, maybe I'll show quickly the LinkML agent here. There's a little bit more going on here than what I showed before. Those of you who are better software engineers may have much better ideas about how to organize this, but the way we decided right now is that for every one of the agents, we would have the actual kind of like agent itself, and then we would have kind of like tools, and then there's something called a bridge to MCP. We don't really have time to get into MCP at the moment, but you may have noticed there's a bit of a buzz about MCP at the moment. We're using the strategy where we bridge towards MCP. One nice thing about MCP is it makes it very easy to use kind of like tools like Claude Desktop. And so you can basically start using any of the agents you define within Claude Desktop. So here's an example that I did earlier, where I kind of like just pasted in a sort of like a figure from a paper, and I said create a LinkML schema for this, and then it kind of calls some of the agents here. But sorry, to go back to your kind of question, let's. I think I have it here. Let's see. Recent. So what I'm doing here is I'm starting up Aurelian with the LinkML agent, and I'm passing this UI option, and we're using the Gradio framework here. And what that basically means is that it gives you a very kind of like plain vanilla UI here, and we've kind of pre-programmed it with some kind of conversation starters, so you can type in whatever you like, standard kind of chatbot. But here, let's ask the LinkML agent to create a schema for some data, and it's going to essentially do the work that you might be done previously in Schema Automator, and it will essentially try and generalize from this very small data example into what a potential schema might look like. Not a very hard task, because there are a bazillion examples on the web of schemas that have name and ID for persons in them. This, sometimes takes a little bit of a while to come back. It's, the LinkML agent is kind of making use of tools that will validate the schema. So, of course, anyone knows you can go into ChatGPT and you can say, make me an RDF ontology or make me a LinkML schema. But it might give you back something that has syntax errors in it or is semantically invalid. The advantage of doing it this way is it's bringing in, it's using kind of tools to do validation. And in this case, it's probably also validating the data against the schema as well. Daniel.
This is a very like high level question, but it's I'm looking at the agent code now. So, or just kind of the fundamentals. How exactly is in the like oaklib agent the code using Uberon? Like, is it giving it a list of just vague things that thinks? So for the default query that like is in the main, what is the Uberon ID for CNS? Is the O4 or the OpenAI model getting a bunch of synonyms and passing that to oaklib? Like, is that's what's going on the back end? Like, what is the like kind of main pipeline of?
Yeah, so if I had time, I considered there's a nice debugging framework that comes with that is kind of loosely coupled with Pydantic AI called Logfire, and it gives you a very nice UI for being able to look at exactly what the LLM is doing behind the scenes. But it takes a minute or two to set up, so I didn't go that route. But so I encourage people to try, as well as just the print statement debugging, which can give you a sense of what's going on, to try using Logfire as well. But I'd say what essentially is happening behind the scenes is not too dissimilar. If you kind of gave a human the task, it'll probably, and again, it's a little bit non-deterministic, but what it'll probably do is say, if you ask it for the term CNS, I'll try querying for CNS and get back those results. But if you tell it the term Brian, but it knows it's in an anatomy ontology, it will say, I think the user probably meant brain here, so I'm going to use brain as, I'm not even going to bother trying to search for Brian, because I know enough about Uberon from reading it that Brian's not in there, but brain is, so it'll probably try with that. Now, it's worth kind of exploring what might happen with other kind of examples. You saw that example that was hardwired in there. It was kind of like hippocampal parentheses, say CA1. So what we had attempted to do with our instructions is to say, just try, if you don't find the right term on the first attempt, try kind of exploring, kind of like break down the term, query for subterms, get a sense of what the terminology is within the ontology, and then build up the queries from there.
Where is that instruction like left? Is there somewhere where, because I feel like I'm looking at the oaklib, unless I'm.
So it's, if we look in Oak Agent, search Uberon, this is the instructions it gets.
So that all this is getting passed to, that's not just a doc string. Okay.
Yeah, exactly. Yeah.
Okay.
Yeah. Good point. Yeah. Crucial point here. Yeah. And, as I was saying to Nico, it can help to reinforce some of this in the actual high level agent instructions as well. Just because, sometimes you just need to be a bit more direct with it sometimes. And if it gets too many tools, then it can kind of get a little bit lost in the weeds, and people are still kind of figuring out the best kind of like balance there between multiple tools. And obviously what I'm showing here is a kind of a pretty simple kind of example where you've got one agent and 2 to 5 tools or something like that. People have found that as you give too many tools to an agent, it can get confused and can go off track. There's various ways in the Pydantic AI docs where you can have agents calling agents, and you can have a kind of even a graph structure for the state flow between a particularly hard problem. I definitely encourage you all to check that stuff out. It's kind of cool, but there's just a lot that you can do with just a single purpose agent with 2 to 5 tools. It can really kind of like help solve a lot of the problems that we have in a lot of our day-to-day kind of ontology and annotation type scenarios. All right, very good. Any last minute question or closing thoughts from anyone? I see some discussion there going on about MCP. Yeah, that could definitely be a good topic for a future tutorial. All right. Well, thank you, everyone. I'm glad that seemed to work well. Hopefully, you all feel empowered to go off and try some experiments now. And I'm sure we'll have a follow-up at some future stage.
Yeah, we will have actually a follow-up relatively soon. So we plan to have 3 sessions around agentic AI in the context of the seminar series. So stay tuned for the next 2 announcements in the near future. So thank you very much, Chris, for this. It was really, really very interesting.
All right.
And thank everyone for coming.
Thank you all.